On this part 3 for ionic bonding, we're going to look at the transition metals. We already looked at Y atoms for bonds. We looked at ionic covalent, where ionic is between the metal sharing its electrons with the nonmetal, and covalent, co being equal valence electrons. The two nonmetals will share electrons. And we have written ionic formulas for compounds made up the S and the P block metals. That's groups 1 and 2 on the left-hand side of the periodic table, and group 13. We're going to write ionic formulas for compounds now with this part 3, for the transition metals in groups 3 through 12. It's the ones between the S and the P block. We quickly review. We said get the symbols correct, write the charges of the element on the top. They must balance. We use the crisscross method where we drop the signs and we wrote them in the opposite corners. If we could, reduce them. And if we wanted to, if it got ones, we didn't have to write them. And then rewrite the formula neatly. And we went through the examples of sodium chloride, magnesium nitride, and aluminum oxide, where we wrote the charges, crisscrossed, and wrote it. In this case, we chose not to rewrite the ones. We had magnesium nitride, where we crisscrossed. We got Mg3N2. I can't reduce that, so I left that alone. And aluminum 3 oxide, also crisscrossed. And we couldn't reduce. So that's what we covered in the last section. And we said the ionic bonds are formed when electrons are transferred from one atom, a metal, to another, a nonmetal. And we said this happens between the metals and nonmetals. These guys have high melting points. They're hard, they're brittle, and they conduct electricity when they dissolve them in water. The transition metals have a sea, like the ocean, or a pool of electrons that makes them have varying or changing ion charges. In order to know the charge of a transition metal, it must be given to you as a Roman numeral, if they give it to you in a formula. Roman numeral I is equal to +1, double I is +2, triple I is +3, IV is +4, V is +5, and VI is +6. So those are the Roman numerals that tell us in a formula what the charge is on the metal. So for example, we have gold 1 oxide. So they gave us Roman numeral number 1. It says gold must be +1. So first step is know the symbol for gold. That's AU. The symbol for oxygen is O. So AU is a +1. How do I know that? Because they gave it to me in the Roman numeral. It's a transition metal. Oxygen is O. It's in group 16. So it has 6 valence electrons. It's a nonmetal. It'll take 2 more to make it -2. I can crisscross. Put the 2 down here, drop the sign. Put the 1 down here, drop the sign. So it's AU2O1. You don't have to write the 1 if you don't want to, but you can. It's fine. And that's the formula for that. Iron 2 sulfide. They're giving us a Roman numeral 2. That means that iron is a +2, that transition metal. Fe +2. Sulfur is also in group 16 like oxygen, so it has 6. It wants 2 more to be -2. So it's sulfur 2, so we got the formula symbols right, and we got the charges right. Crisscross, and you have Fe2S2. Here's where a pair we can reduce them. We can divide them both by 2. So if you can't reduce, you must. Now you could have put Fe1S1 or choose not to write the ones. Your choice. And then for the third one, copper 1 nitride. Again, this copper form of the transition metal copper is a +1. They told us with Roman numeral 1. So copper is Cu +1. Nitrogen is N. It's in group 15, so it has 5 valence electrons. It wants 3 more to get to 8, since it's a nonmetal, so it'll be a -3 when it gets them. Crisscross, and you get Cu3N1. That's how we write formulas with transition metals, using the Roman numerals. What if you're given a formula with the transition metal, in this case gold, and they ask you, what's the charge on this? Because remember, the charge could be any one of several charges. The question is, for this compound, what is it? So how do you know the charge on the gold if you're only given the formula? There's a couple ways we can do this. I'm going to take it through the department way, and then I'm going to say we got an easier way. You choose. So what do you know? You know that the charge on the group 16 nonmetal, oxygen group 16, so it wants 2 more, so it'll be a -2. That much we know. And since oxygen is a -2 and there are 3 of them, that means 3 times -2. So far, the 3 oxygens are contributing a -6 charge to the compound. And we want it to be neutral. So this has to be a +6, the metal. So to have that, the -6 has to be balanced out with a +6 for the metal. Well, I've got 2 golds, and I need +6. Then the charge for each one of the 2 golds must be a +3. 2 times +3 is a +6. That will balance out the -6. So it's like 2 times what would be a +6? Well, 3 times 2 is a -6, so I need a 2 times a +3. That will balance them out. That'll give you, that means gold has a charge of +3 for one of them. Since I got 2 of them, that's a +6. Oxygen is a -2. Since I got 3 of them, I have a -6, so that's neutral. That's the charge on the transition gold in this case. Where in our last slide, it was a +1. So it just depends on how it's formed. And since we're going backwards when they ask us from the formula what the charges are, we're going in the opposite direction of what we did before. A reverse crisscross will work here. But just remember to add the plus sign to the metal on the left and add a negative sign for the nonmetal on the right, and you'll be good to go. So to find the charge for gold oxide, you have the gold. There's 2 of them. Oxygens, there's 3 of them. Since there's 2 of these, I'm going to use the reverse crisscross. So I'm going to put a 2 up there. But since it's a nonmetal over here, I got to make it a minus sign. Oxygen's a nonmetal. And then I'm take the 3 from the oxygen. I'm going to put that over here. But since this is a metal, that'll have to be a positive sign. +3. And so we got the same result. Au +3. Oxygen's -2. That's how you find the charge on the transition metal. You can just simply use the reverse crisscross. Chemical formulas represent the composition of the compound. It tells you what elements are present and how many atoms of each of those elements there are. You saw there was 2 golds and 3 oxygens in the last one. Atoms and ions combine chemically in definite ratios. Oxidation number charges on polyatomic ions, which we'll talk about later. We talk about formulas. They'll use this on how to combine them in ratios. But bottom line is when you get a formula that's correctly written, all the charges will add up to 0 in the compound. The compound will go back to neutral. Just like the atom was neutral to begin with, until it wanted to be stable and add electrons or remove them from valence shells, making them positive or negative, they get the neutrality back by combining in whole number ratios to make the resulting compound neutral. Ionic bonds have other important properties. So what happens when we took water and we put sodium chloride in the water and dissolved it? Ionic compound dissolves in water and the ions will separate from each other. And when they separate each other, that's because their electrons were exchanged. The electron came off of this and went on to here, making this a negative ion, making this positive because they had stable outer shells. And the water molecules surrounding this keep them apart and keep them from reforming. The tendency of ionic compounds to break up into ions when dissolved in water is important. So the ability for them to do this is very important. Hardness of water is determined by the amount of dissolved calcium and magnesium atoms, which are not shown here. That'd be Ca +2 and Mg +2. Those guys are floating around here as well. Many substances transported in your body are dissolved ions. And these ions are called electrolytes. You've heard of them before? That's what you're talking about, these metal and nonmetal ions in your system. and in a solution that allows water to conduct electricity. The ions carry the electric charge. So electron will bounce from this to this to this to this. It forms a circuit. That's why your body needs it. You need both salt and water in your body for electrical impulses on your nerves to carry out their instructions on making muscles react, make your heart beat, make your lungs breathe. It's required. And that's